Hello my friends, I welcome you all to my YouTube channel Cosmic Codes. In today's video I am going to implement a neural network using the Arduino IDE, which is very close to C and C++ format. So in this sketch nothing important is going to happen, but this sketch will build up the initial concept of the artificial neural network. Okay, so first I'm going to start what this neural network does is to recognize a button press, and when the button is pressed it will toggle the LED state of the LED. Okay, you can see that the button pin is connected to pin number 2, digital pin number 2, and the LED pin is connected to pin number 13. Okay, so you can see that this code does the same job. Here you can find in the examples the digital and the debounce code. So this code is what our neural network does is very similar to this debounce of code, but we do it in the unconventional way. Okay, so these variables are for the debouncing purpose, so we don't need to explain that right now. So here you can see that number of input neuron, I have set the number to 1, the number of hidden nodes is 3, and the number of output nodes is 1. So our neural network has one input, one output, and in between the input and output layer there is a hidden layer, and in the hidden layer there is 3 neurons. Okay, so this matrix is the weight matrix between the input and hidden layer, and this matrix is the weight between the hidden and the output layer. Okay, so this matrix is for the bias vector of the hidden layer, and this is the bias vector of the output layer. These are the 3 hyperparameters: learning rate, threshold, and expected output. So our neural network will try to achieve this output value. It will start from any random value, then it will stop at this, it will try to converge at this value, and when this value is the actual output value is crossed this value, the toggling action will be seen. Okay, now the input data is stored in this array, and the output of the hidden layer is stored in this array, and the output of the output nodes is stored in this array. Okay, yeah, error in the hidden layer is stored in this variable, and the error in the output layer is stored in this variable. Okay, this array. Now here you can see I have set the activation function of the hidden and the output layer to be a sigmoid function. Now the sigmoid function I have explained it in the earlier videos, you can check on that. Now the custom the user made function is this void initialize artificial neural network. In that I have initialized the WIH matrix to a random value between -1 to +1. This statement will generate a random number between -1 to +1, any fractional value initially. The WHO matrix is also randomized. The bias of the hidden layer is randomized, and the bias of the output layer is also randomized. Now in the setup function you can see that I have called the initialize ANN function. Now there is another user made function which is called forward propagation. This is the you can say this is the feed forward mechanism. We have fed the input layer with the button state. Okay, then the neural network will compute the input value, and it will generate an output. Okay, so you can see that this is the weighted sum of the pre-state of the input layer, and this is the output of the hidden layer, which is the in which we have applied the sigmoid function. Next you can see that we have calculated the pre-state of the output layer, then activation function is applied, and here you can see that I have printed the output value upon the serial monitor, okay, up to 3 decimal places. Now in the propagation user made function, you can see that I have calculated the error in the output layer by this formula. Then I have calculated the error in the hidden layer by this formula. Then I have adjusted the WHO matrix using this formula, okay. Then I have adjusted the WIH matrix according to this formula. Also I have adjusted the bias of the hidden layer, and I have adjusted the bias of the output layer. So this is the backpropagation algorithm. This function is the backpropagation function, this function, okay. Now in the loop function, you can see that this part is very similar to the debounce part, but in the body we have called the forward propagation function if the button is pressed. And after forward propagation, it produces an output. So if the output is greater than the threshold, then the LED toggling action will be in action, and the state will be print on the serial monitor, okay. Now in the else part of this if statement, we have put nothing because we don't want to do anything. Then we called the backpropagation function to minimize the error, because as you can see that the biases and the weights are initialized randomly in the first place, but as this random values of weights and biases produce an output which is very inaccurate, and it is with error. So then we calculate the error, and then we adjust the weight and biases so that we can achieve this value, this target value, this expected value, okay. And when this targeted value is approaching 0.8, when it is greater than 0.7, the LED toggle action will occur, okay. So this is the total code. Now I'll upload it to the my Arduino Nano. You can see that I have the Arduino Nano connected in the USB 0 port, okay. So I'll upload it, and then I'll show you the output of this program. Here you can see nothing is in the output, but when I press the button, there is a random number generated. Now if I press the button second time, you can see that it is approaching, it is increasing, and it is approaching 0.8. You will see in a moment, but as the value crosses 0.7 mark, you can see that the state change has happened. Now the LED is on, so the state is 1, and if I press it again, the output value will increase up to 0.8, but the LED toggle action is happening. You can see that the LED is toggling very nicely, but if I press the button continuously, then you can see that the value is approaching 0.8, which is our expected output. So the neural network is learning, actually it is learning to adjust its biases and the weights of its connections in between the layers to produce the correct output, the expected output, okay. Here you can see that the toggling action is going on quite well. It is very close to 0.8, as you can see now. So we can say that after the output value is crossed the mark of threshold, we can say that the neural network has learned the task, okay. Now you can see that as the error minimizes, the rate of increase is decreased, okay. So now you can see we are very close to 0.8 mark. So after that we will stop our experiment and I will end the video. Yeah, you can see that the expected output is achieved. You can achieve this expected output very much rapidly by adjusting the learning rate. You can see it in here, the learning rate. I have set it to be 0.5. You can increase it or decrease it according to your requirement. So this is the artificial neural network tutorial for today. I'll post this code in the community, so you can copy it from there and use as your own purposes. Okay, so goodbye my friends, and I will see you next time.